Hello, advanced algebra students. Welcome back to our second video lesson on discriminants as we continue to examine the effect that discriminants have on the type of solutions and helping us to identify real or imaginary numbers. And so one of the questions on yesterday's practice inside of the packet talked and asked about, are the solutions rational or irrational? And really the difference between rational and irrational lies within the decimal part of a number. Irrational, they continue on and on forever. They don't have an ending, like pi or square root of 5 or square root of 15. Like these numbers are irrational because they don't have a true ending. Rational numbers, they do have an ending, like 1/2, which is 0.5. -4 has an ending, like -4.0. We know that 0.3333 repeating, we know that the ending is going to be 3. We just have no idea where. We can also write this as a fraction, 1/3. Or this 1 squared root of 25 is 5. So that would be rational because it has a definitive ending. So will these solutions here be rational or irrational? Well, if we try to simplify those, 4 plus or minus the square root of 49 becomes plus or minus 7 over 3. 4 plus 7 over 3 is 11/3. Or 4 minus 7, which is -3 over 3 is -1. And because of that, these are both rational. I can write them as fractions. The key here really lies in that square root, right? The square root of 49 we know is rational because we know it. It's 7. It has an exact answer. All right, and that's kind of the key to that piece. But now let's keep moving back or going back to our discriminant, where today we're going to look at the application of the discriminant, the quadratic formula, and how this relates to perhaps story problems. As we discussed, we can use that discriminant to help us identify what type of solutions we have. And in a story problem, that helps us identify if we have any real solutions. We got to make sure that we're going to read the problem carefully and think back to some of our previous work where it wants to know if it reaches a certain height. And so we might have to set the equation equal to something to see if it reaches that height. However, when we are using the discriminant or the quadratic formula, our equation must equal 0. Now, I'm still working out of the packet. I'm on page 11 and number 4. You may need to use your calculator on this one if you want to. You're probably going to have to because there's a decimal. So the equation h equals -0.4x squared plus 2x plus 2 models the path of a ball where x is the horizontal distance in feet that the ball has traveled and h is the height of that ball's path. Use the discriminant to determine whether the ball ever reaches a height of 4. Will it ever reach a height of 4? So we want to know, does this equation ever equal 4? And so I'm going to set that entire piece of information, the equation for the path of the ball, equal to 4. And now we want to know if this ever reaches a height of 4, meaning all we've got to do is use the discriminant to figure out if it does. Because if it has 2 real solutions, it's definitely going to reach that height of 4. Because we've set the equation equal to 4. But before we can evaluate the discriminant here, we have to make sure our equation equals 0, which is going to change the c value in this problem. And that's how we then will know whether or not it does indeed reach the value of 4. And so there it is. And now we can plug it into the discriminant, b squared, which is 2 squared minus 4 times a. Oops. Let's go back and erase. -0.4 times -2. 2 squared is 4. 4 times -0.14 times -2. I'm going to go to my calculator on my phone. 4 should get negative 3.2. So we're going to subtract 3.2, meaning we get 0.8 for the discriminant after we set the equation equal to 0. And because 0.8 is indeed greater than 0, we can say, yes, the ball will reach 4 feet. And in fact, it'll actually reach 4 feet twice. If you think about the path of a ball, it's going to go up and it's going to hit 4 feet like maybe here, but it's going to keep going beyond 4 feet. And then all of a sudden it'll start to come back down where it hits 4 feet again on its way back down. And all because we know it has 2 solutions because the discriminant was greater than 0. But the key started by setting the equation equal to the height we were looking for. Does it pass the height of 4 feet? Setting it equal, and then moving that over to find our A, B, and C values properly. That's how we can apply and use the discriminant. Now, other types of questions, and this is my hint to you, is this is like a test alert. You know, if I had sirens, I'd play them. A test alert. Can you find all of the A values in this formula, this equation, so that we only have one real root or one real answer, solution, right? Remember that a root is the same thing as a solution. It's also the same thing as an x-intercept. We used them differently when we were graphing. So I want one real solution. Well, that means that b squared minus 4ac has to equal 0. That discriminant has to equal 0 if I only want one exact real solution. I'm going to plug these in. B squared, which is 48 squared, minus 4 times A. Well, that's what we're looking for. We don't know the A value. Times C, which is 64. Can we get that equal to 0 for what A value? And then we need to simplify. 48 squared is 2,304. I can multiply 4 by 64 to get 256a equals 0. Forgot the a value. And now we're really just working backwards to solve for a. I'm going to subtract 2,304, meaning negative 256a equals negative 2,304. And then we would have to divide by negative 256. And if we go ahead, you're going to have to use your calculator on some of this because I don't know that you can do all of it in your head, but you might. A would be 9. So the only value that we could plug up into this original problem up here to give us one exact real root would be the value of 9. All right, and that's all coming again from this discriminant. Now the second one here, again, test alert, right? What values of A will give us 2 real roots, 2 solutions? Well, if we're looking to get 2 solutions, b squared minus 4ac must be what compared to 0? It's got to be greater than 0. We want anything that's higher than 0, not equal to, because that would only give us one answer, but anything greater. So same process that we just used. 3 squared minus 4 times the a value that we don't know, times the c, which is 5, or 9 minus 20a has to be greater than 0. This time, I'm going to move the 20a to the other side because I want everything to be positive. And then we'll divide by 20 such that 9/20. So A has to be less than 9/20. Anything that is less than 9/20 or 0.45 would give us two real solutions, two real roots in this problem. Now, you got to be careful on this step right here, because let me just show it over here. If you decided to move the 9 over, -20a greater than -9, you got to remember the rule for dividing by negative values and inequalities. Whenever we divide by a negative, the inequality sign switches. Only if we divided both sides by a negative. So anything that's less than 9/20, -500 would work. Negative, 8 would work. Any of those numbers. Last one. Find all values of c such that 2x squared minus 6x plus c equals 0 has two imaginary roots, imaginary solutions. So now we are looking for b squared minus 4ac to be what compared to 0? If we want imaginary, it has to be less than 0. We need negatives. So b squared, which is going to be 36 minus 4 times our a value times our c, which we don't know, has to be less than 0. 36 minus the 8c is less than 0. I'm going to add the 8c to both sides so that I'm working with a positive coefficient. And now I divide by 8. Or c has to be greater than, let's see. If I divide everything by 2, nope, we're going to divide by 4, 9 halves, 4.5. So c would have to be any number greater than 9.5 for us to have two imaginary roots, to have this negative discriminant. And so we can, again, use this discriminant to help us find values that fit certain quadratic equations and give us a certain type of solution we are looking for. If you have any questions, please make sure that you reach out. We do have a test coming up relatively soon, so if there's anything you don't understand, let me know. Otherwise, until next time, everyone, stay safe.